We're now going to work an example problem involving both mass fractions as well as mole fractions. So let me begin by writing out the question. So there's our question. We're given a question involving moist air, and so that is our gas mixture. And we're told that 78% of air is in nitrogen, 20% is in oxygen, and the remaining 2% is in water vapor. And what they want us to do is determine the mass fractions of each of the constituents within the mixture that we call air. So let's begin. What we'll be doing here is we'll be using both the concepts of mass fraction and mole fraction. So to begin with, let's write out what we know. We are told that on a molar basis it is 78% N2. That means that that would be the mole fraction of nitrogen. Similarly, for oxygen, it was 20%. And for the water vapor, it is 2%. And the other thing that we're going to want to do at this point is we are going to want to look up the molar masses in the tables in the back of your books. So any thermodynamics book that you're using should have tables in the back. I am using Cengel and Boles, and there's a table, it's table A-1, and that's one where it has the different values that we will need for this. So I'll write those out now. So those are the molar masses. Now what we can do, we can use the equation that we looked at in the previous segment, and that is for the molar mass of a mixture. And if you recall, we said that it was the summation of each of the different mole fractions multiplied by the molar mass of each of the different components. So we can go through, we know the mole fractions, and we know the molar masses, so we can go ahead and evaluate this for our mixture. So for our mixture, in 1 kilomole there is 28.61 kilograms. So we're now going to use that, enabling us to determine the mass fraction. So that is the molar mass of our mixture. So let's go ahead and take a look at the mass fractions. So by the definition of mass fraction, let's take a look at nitrogen to begin with. We can say the mass of nitrogen divided by the mass of the mixture. Now the mass of nitrogen, what we're going to consider here is we're going to consider looking at only 1 kilomole. So in 1 kilomole, we can write out how many kilograms there are of nitrogen. and then that's divided by the mass of the mixture itself. And in a similar manner for oxygen and water vapor, so those are the answers that we're looking for. That's the mass fraction of nitrogen, oxygen, and the water vapor. And so with that, that concludes the example problem, giving us application of both mass fraction as well as mole fraction.